project, we have to identify physics in our everyday world. To describe both acceleration and velocity, our partner Nathan is in his beautiful car. He's going to accelerate with velocity from point A to point B, that light post. Acceleration is the distance traveled divided by the time interval. We are going to time the time it takes from point A to point B and subtract the final velocity minus the initial velocity, which will be 0 miles an hour. 5.4 seconds. So our friend Nathan had a final velocity of 32 miles an hour. Velocity is any speed in any particular direction. He didn't have a constant velocity because he accelerated from 0 to 32 miles an hour in 5.4 seconds. Let's go do some math. To find our friend Nathan's acceleration, we're going to use the equation to find acceleration, which is acceleration equals change in velocity divided by time. So we're going to take our final velocity of 32 miles an hour, and after some figuring, we came to the conclusion that 32 miles an hour equals 13.7 meters a second. So we're going to convert that. So 13.7 minus an initial velocity of 0 meters a second equals 13.7 meters a second. So if you take that divided by the time it took to get from point A to B, which was 5.4 seconds, you get, Nathan?
2.53 meters per second squared.
2.53 meters per second squared. So his average velocity from average acceleration from point A to point B was 2.3 meters a second squared. Nay. Our next term to identify in the real world is inertia. Inertia is the reluctance of any body to change its state of motion. And mass is the measure of inertia. So, which car here has more inertia? Nathan's Acura or Grant's Durango? Let's see, which car is more massive, the Durango or the Acura? I think it's safe to say the Durango because it's quite larger. So, which one is going to take more force to move it? The Durango or the Acura? Well, let's say the Durango is twice as massive as Nathan's Acura. That means it would take twice the force, so a stronger engine to move this car than Nathan's. And that's inertia. Our next term to identify in the real world is F equals ma, or force equals mass times acceleration. F equals ma is the same equation as W equals mg, because weight is a force, mass is mass, and gravity is an acceleration. Nathan and I are going to weigh ourselves to find out how much gravity affects both of us in comparison to our masses. After that, we're going to go do some math. I'll choose our handy dandy scale to find out that I weigh 123.5 pounds. Nathan, your turn. How much do you weigh, Nathan?
160 on the dot.
Let's go do some math! Okay, I just did some math here to find out mine and Nathan's mass. I weigh 123.5 pounds and used Google to convert pounds to newtons because they're both a force or a weight. It turns out I weigh 543.4 newtons, and Nathan's 160 pounds comes out to 704 newtons. Now if you plug that into the equation, W equals mg, 543.4 equals m times 9.8, the acceleration due to gravity at Earth. So if you take 543.4 divided by 9.8, it comes out to a mass of 55.4 kilograms for me. Now Nathan, his 704 newtons divided by the acceleration due to gravity, which is 9.8, comes out to 71.8 kilograms.
Well, Newton's third law of motion, which is going to be the next term we're describing, is with every action there's an equal and opposite reaction. For this one, we're going to use Grant Brown right here in the brick wall. Grant will push against the brick wall with about 50 pounds per square inch onto the wall. And if Newton's third law holds up, the brick wall will also push back with 50 pounds per square inch. So, for every action, there's an equal and opposite reaction, and Grant pushes the wall pushes back. So it creates the equaling force, and neither of them go down.
Oh, hi there. Now I'm going to show you an example of a collision. A collision is when two objects, both with force, come in contact with each other. Now there are two separate types of collisions, elastic and inelastic. An elastic collision is when both objects collide with each other, then bounce off of each other and both return to their original shape. An inelastic collision is when the two objects collide, stick together, and don't return to their original shape. Today we're going to show you an example of an elastic collision with this soccer ball and this basketball. Elastic collision! Now we're going to talk about center gravity. The old ancient sword masters used to say that if it was a good piece, the center of gravity must be where we're playing. The next term we're going to discuss is friction. Friction is the force that acts to resist the relative motion or attempted motion of objects or materials that are in contact. In other words, friction is the force that allows materials to move easily or not so easily. An example of this would be sled and snow. If you have snow on the ground and the ice and the sled moves over the ice really easily because there's no friction. But if a sled and there's no snow, we'll see how that works. Well, now this is because of friction, gravity, and the sled is very, very high. This means that it will not go very far. Now we're going to talk about a hypothesis. A hypothesis is an educated guess about the outcome of an experiment. Now this experiment is going to be our team member Grant swallowing a spoonful of cinnamon. Now there are two ways that this can come out. He can swallow it and be fine, or he's going to cough it up like a 60-year-old smoker. I hypothesize that he won't be able to swallow it and he will cough it up like a 60-year-old smoker. Let's see how it happens. Grant, swallow away. Looks like my hypothesis was correct. And that's number 10. That sums up the project.